All right, guys, let's go ahead and go over our study guide for Unit 1. Okay, so translate 5 units to the left, so that's going to be x minus 5, and 5 units down, so y minus 5. And we're going to do that to this point. So we're going to do negative 4 minus 5, and we're going to get negative 9. So we have negative 9. And we're going to do 6 minus 5, and we're going to get 1. So our new point would be negative 9, 1. All right, rotate counterclockwise 90 degrees. Well, that's when we have our x and our y. They swap places, and our y becomes opposite. So they're going to swap places. Oh, counterclockwise 90. Sorry, I went 270. Just one moment. All right, so I totally jumped down to clockwise and was correct, counterclockwise. So they switch places and the y becomes opposite, making this positive 6 and the 3 staying the same. Rotate clockwise 90 degrees. That would be your x and your y switch places. And this time, that's a nice arrow, your x becomes opposite. So y and your x becomes opposite. So in this case, it was negative 6 was our y. It doesn't change. And then our x becomes negative. So negative 6, negative 3. All right, rotate 180. Well, that one's not too bad. All that happens here is we have x and y, and they just switch values. So it becomes negative x, negative y. Well, in this case, our x is already negative, so that's going to become opposite. And our y is positive, so it'll become negative. Okay, if point A, 2, negative 10, is reflected over the y-axis, when it's reflected over your y-axis, your x becomes opposite. So it becomes negative 2, negative 10. So you have x, y, and when you reflect over the y-axis, your x becomes opposite. So negative x, y. This one says your x-axis, so you have x and y, and your y is going to become opposite. So you have x, negative y, which gives you the point negative 3, positive 8 now. Okay, moving along, reflected over the y equals x. Remember, if we were to graph that, that would look like this. And the coordinates of c, well, if you remember, when it's reflected over the positive, you have x and y, and all they do is switch places. So you have y, x. So that's just going to become 3, negative 7. All right, well, now we have x and y still, but this time they're reflected over the y equals negative x, which means that it would go down like that, and they would still switch places, but this time their values would also become opposite. So you would have a negative 3 and now a positive 7. Okay, so if D, which is 6, negative 4, so over 6, down 4, so there's D, is reflected over the y equals 2. Well, this is our x-axis, this is our y, and y negative 2 would be right down here. What would the coordinates of D prime be? So remember, when it's just a line like this, you count however many over. And it's 1 unit away, so D prime would be 1 unit away. And that new coordinate, oh, whoops, I did not move it down far enough. Sorry. It would be 2 units away. I did not move it down 4. 1, 2, 3, 4. is where it needs to be. And then our new coordinate would be right there. So over 6 up 0. Okay, the difference between a rigid motion and a non-rigid motion. A rigid motion, it preserves the size and shape of a figure. And a non-rigid motion can alter the size and shape of a figure. Okay, so that's that one. Let's go ahead and move to the next page. Question number 12. Oh, whoops, that's 17. That's right, because I have this copied all wonky. Sorry about that. Okay, so question number 12 is, all right, perform a sequence of transformation that slides all points 6 units up, then reflects all points over the y-axis. So we want to find the image of -3, -2. All right, and I'm just going to call that point A. The first thing it does is slides it 6 units up, so 1, 2, 3, 4, 5, 6. That would be A prime. And then it reflects it over the y-axis. So here's my y-axis, and it's 1, 2, 3 units away. So I'm going to count 1, 2, 3 units this direction. And I'm going to label that new point, which my new point for A double prime is 3, 4. All right, so this one is a bit tricky. You want to see what's happening to each of these, and let's see if it works. So I'm going to do -2 plus, let's just say, n for a number equals -6. That's how I'm going to solve for my x value. All right, so I'm going to add 2 and add 2. I'm going to get n equals -4.
Berlin, Sanchez, please come to the...
Sorry about that, guys. I'm making this at lunch. Okay, so n equals -4. What we want to do is we want to try that with all of our new points. So -2 minus 4 is -6. That checks. All right, 6 minus 4 is 2. That checks. And 1 minus 4 is -3. So we know that our rule is x minus 4. So let's do 3 minus 4, which will give us -1. And now let's figure out our y, because we know our x. So we want to see how we get from 1 minus a number and we get to 0, right? Because we go from 1 and we end up at 0. So I'm going to subtract 1 and subtract 1 and get -m equals -1. Well, I gotta get rid of that -1. So I'll multiply both sides by -1 and get m equals 1. So let's try it. 1 minus 1 equals 0. Yeah. 4 minus 1, whoops, we're not there. -1 minus 1 is -2. Yep, works there. -4 minus 1 is -5. Yep, works there. And let's go ahead and do that. So y minus 1, right? It's going to be 1. Then we're just going to subtract 1 from 4, and we'll get 3. All right, -1, 3. Down here it says write an algebraic rule in coordinate notation for a translation that moves a triangle 5 units to the left. So we're moving to the left and up 6 units. So if we move to the left, that's subtracting. And since it's left or right, we know that it deals with our x-axis. And since this is up or down, we know that up or down deals with our y. So it's y plus 6. Okay, well, I'm going to go ahead and graph this. So I have -3 up 2. I have -1 up 6 and over 6 up 1. Okay, the tricky part here is graphing over the y equals -1. So y equals -1. Here's my y-axis. Here's my x. -1, just down 1 point. Okay, so I'll go ahead and I'll graph that. And I'll graph that by counting how many units away it is from the line, right? Because there's no specific rule. So 1, 2, which means C prime is going to be 2 units away. So C prime. B is a whole lot of units. 1, 2, 3, 4, 5, 6, 7. And I'm going to count on this side. B prime will be right here. And A prime is going to be 1, 2, 3 units away. All right. And there's my new figure. Hopefully your lines line up better than mine do. Okay, and we're just going to label these new coordinates. And hopefully you have -3, -4, -1, -8, and 6, -3. All right, let's move on to question number 17. Okay, some patty paper. Okay, so what I'm going to do is, if you have patty paper, that's awesome. If not, don't fret. Okay, so I'm going to make sure that I label the points. That way I know where they are once they move. And if you prefer the rules, you're more than welcome to use the rules. Okay, so it says rotate the square 90 degrees clockwise. So I'm putting my pencil there and rotating it until the x and the y axes line up. And I have C right here, D right there, B right there, and A right there. And I can just go ahead and try to graph them based on where I had my points. So this was D, A, B, and C prime. All right, and I'm going to go ahead and I'm going to label those new points. So that would be for A, 7, 6. For B, 6, 2. For C, 2, 3. For D, 3, 7. Okay, that's great. Now it says reflect over the x-axis. So here we are. And now remember, reflecting is kind of like a flip. So flip it over and we'll plot our new points again. So just make sure your x and y axes are lined up. And if you'd rather use rules, that's fine. Remember, this is C, B, A, and D. All right, so I'm going to go ahead and plot those points now. C double prime, B double prime. All right, and think I might have just drawn my line a little off. Anyhow, your new coordinates, once you've reflected, your y's are just going to become opposite. So 7, negative 6, y's are opposite because we reflected over the x. 6, negative 2, 2, negative 3, and 3, negative 7. Okay, so here we go for the next one. Reflect triangle JKL over the y-axis and then rotate 270. Okay, so I'm going to use the same piece of patty paper, but, oops, I'll use it this way. Yep, here. That way I think I can see a little bit better. And I'm going to plot my points. Plot my points using pen, J, K, L. Kind of trace so I get an idea of the shape. Ooh, wobbly lines. All right, and it wants me to reflect over the y. So I'm going to flip it this way. All right, and remember, when you reflect over the y, that makes your x opposite. So here's my new J, my new K, and my new L. Oh, and don't forget the prime markers. Okay, so we'll go ahead and write those as negative 5, 7 for J, negative 8, 1 for K, and negative 1, 0 for L. Okay, then it says, hey, now we got to rotate this 270 degrees clockwise, which means 3 turns, right? So here we go. 1 turn, 2 turns, and 3 turns. Wow, I kind of got a little excited there. So, gosh, I'm really stinking at lining up. It's hard to film and line everything up all at the same time. Okay, so this was our J, this is our K, and this is our L. Double prime. And as sloppy as it is, that's where it ended up. It almost looks like a little windmill. Okay, so that would be negative 7, negative 5, negative 1, negative 8, and 0, negative 1. That's if you're using the patty paper. If you prefer the rules, that's completely fine. Okay, so moving on, it says write a rule for the transformation below in coordinate notation. What will map the pre-image to the image? So this is one where I really think that you guys should use patty paper. And I'm going to use a fresh new piece. I'm just going to kind of trace my x and my y axes just so I have an idea. And I'm going to plot E, F, C, and D. And my hope goal is that I want my D to line up with my D, my E to line up with my E, and so on and so forth. I don't think any rotation really is going to do that, nor do I think a flip or a reflection would, because then they're all on the wrong side. So it's a little bit of trial and error, and what we're going to do is we're going to move it to the left. All right, it looks like I went over 9 places, so I'm going to write x minus 9 because I moved to the left, and then how many units do I have to move up? Oops, from there. Looks like I move up 4 places, so y plus 4. All right, and that's our pool. Okay, let's move on to the next chunk. Got to find it in this confusing copy of papers that I made. All right, so we should all be on number 20. And number 20 is kind of friendly.
Mason, Farrell, please.
Okay, So what you want to do is you want to find the points that are the closest together. All right, and you kind of want to mark that. And mark it until you see what axis it's crossing through. And in this case, it's crossing through the y-axis. So your line is going to be y equals, and then you look and you see what point on the y-axis is it? Well, it's just over 1, so it's y equals 1. Okay, next step is write a sequence of 2 transformations that will map the pre-image onto the image. So I'm going to just go ahead and move this so that I can reuse this. So here's L, M, and N. And I see that L is kind of down there, which makes me think that I'm going to need to either rotate or flip. So if we flip, we see that L is kind of in the wrong area. So let's flip back and see where we end up with rotations. So maybe I rotate 1 turn and 2 turns. Ooh, N is in the spot where it should be, L is in the spot where it should be, and M is. So that looks right. Let's say rotate 180 degrees. And remember, rotating doesn't matter. It could be any order. And then we're going to move down, so, or over. And let's move left to right first. So we want our N to line up. So 1 to the left, and then it's on the same thing. So we're going to have X minus 1 because it moved over. And now we're going to see how many units down, which is also going to be subtracting. So 1, 2, 3. So Y minus 3. Okay. Let's look here. It says name 3 collinear points. Well, Q, P, and T all lie on the same line. So Q, P, and T, that would work. R, P, and U also lie on the same line. So you could say R, P, and U also. 3 non-collinear points. Well, here's Q, here's R, here's S. They're not on the same line. So Q, R, and S would work for 3 non-collinear points. So give another name for QT. So I went ahead and said TQ, right? Just naming it backwards. Or this isn't really labeled very well, so if you saw it as a line, you could name it TP if you saw it as a line. Sorry. And give 2 other names for angle 1. Well, I could name it QPR because angle 1 is just talking about the space right here. So angle QPR, or I could go the opposite way and name it angle RPQ. Okay, the sides of angle 2, remember the sides are raised, so we would want to say PR is one side and PS is the other side. All right, classify angle SPU. So SPU, that's from all the way over here. That would be an obtuse angle. And classify RPU from R to P to U. Well, that just forms a straight line, so that would be a straight angle. My L is invisible there. And then last but not least, our final page. So we need to add these fractions, right? Well, we can't add them unless they have common denominators. So I'm going to multiply this side, meaning the top and the bottom, by 4. And this side, meaning the top and the bottom, by 3. So 9 over 12 plus 8 over 12. Now they're all lined up and we can add. So 17 over 12 is our answer. All right, and I know there's been a lot of talk about this in some classes, but always use your grouping symbols, parentheses first. If you like the box method, that's great. Do the box method. If you don't, you can do the FOIL method. All right, x times x is x squared. Negative 6 times x is negative 6x. 3 times x is 3x. And negative 6 times 3 is negative 18. All right, so I'm going to put a 2 on the outside of the parentheses and go x squared minus 3x minus 18. And now I'm going to distribute. So 2x squared minus 6x minus 36 would be your answer. All right, factor completely. This one, there's no GCF, there's no number out in front of x, so we'll just make our x factor. Negative 14 to the bottom, 24 on top. What multiplies to a positive 24 but adds to a negative 14? That would be negative 12 and negative 2. And your factor would look like x minus 12 and x minus 2. All right, here, there is a GCF. Everything is divisible by 2, right? So I'm going to pull the 2 out, and I'm going to have x squared minus 7x minus 44. Okay, and when I go to factor, I'm going to write my parentheses, but I'm going to put the 2 out there so I don't forget it. And now I'm just going to factor this. So negative 7, negative 44, which should be negative 11 and 4. So we have x minus 11 and x plus 4. Okay, solve the following equations. I'm going to distribute here. So I have 6x plus 21 equals 39. I'm going to subtract 21 and subtract 21 and get 6x equals 18. Divide by 6, and get x equals 3. Over here, distribute. There's no like terms to combine, so I end up with 10x minus 35 plus 4 equals 7x minus 1. Okay, now I have some like terms right here, so I'm going to combine those. 10x minus 31 equals 7x minus 1. Okay, I'm going to subtract 7x, move it over to the left, minus 7x. And I'm going to end up with 3x equals, well now, I'm going to add 31 and add 31 and get 30. I'll divide by 3 and divide by 3 and get x equals 10. Boom. That's it for our study guide, guys. Good luck. Please let me know if you have questions. All right. Bye.